Okay, good day everyone. Today we are looking at another type of compound angle. So the compound angle we will be discussing today is your sin A plus minus B. And then we will move on to proving some compound angles, for example proving the left hand side is equal to right hand sides, and then we will look at some of the identities and we'll go and prove that. So let's start with the sin A plus B. So if we have to prove the sin A plus B is equal to your sin A cos B plus cos A sin B. So the question can come out like proof that sin A plus B is equal to sin A cos B plus cos A sin B. If we are able to prove this, then we will understand the compound angle sin A plus B. So let's start with the left hand side. You know, when the question says proof, then we are going to divide the part left hand side and right hand side, and then we are going to use one of the sides to prove that this side is equal to the other side. So we are going to look at the left hand side. We are going to use the left hand side and start proving that the left hand side is equal to your right hand side. So the left hand side says sin A plus B. We need to simplify this. In order to simplify this, we can use the co-ratios we did in grade 11, and we can say that sin A plus B is equal to your cos 90 degrees minus A plus B and brackets close. So sin theta is equal to cos 90 minus theta. So in this case, sin A plus B is the angle. So we are saying cos 90 minus the angle A plus B. We are using the co-ratios to find the value of sin A plus B is equal to cos 90 minus A plus B. Now we are going to multiply this minus and open the brackets, and we will be left with your cos 90 minus A minus B. Next step is to make the group. So we can group these two together now. So using the rule, your cos A minus B, which will give you cos A cos B plus sin A sin B, or sin A sin B. So how we're going to write when we group this? We can say that the cos 90 minus A cos B, there's a negative sign in the bracket, so we will use positive sign, and then we will say sin 90 minus A times your sin B. Now this is the compound angle rule we use, the one we have been discussing in previous videos, and then we have opened this or expanded this sum into cos 90 minus A cos B plus your sin 90 minus a and sin b. Now we are going to simplify this. So after we group, we got this, right? Now we are going to simplify this compound angle, and we can say that if you look at this and this one angle cos b and sin b is another angle. So we can say, using the compound angle rule, that cos 90 minus a is equal to sin a cos b plus your cos a and sin b. So we can use our co-function rule and to simplify sin 90 minus a. So this is a cos a, and cos 90 minus a is equal to your sin a, and then hence prove that left hand side is equal to your right hand side, and we have proved that sin a plus b is equal to your sin a cos b plus cos a sin b. Now the pattern here we need to identify is that sin cos cos sin. This is the pattern we need to identify, right? When we were looking at cos alpha minus beta, it was cos cos sin sin, right? The pattern was cos cos sin sin, and then we give angle, one angle each to cos and sin, and then we look at the positive sign or negative sign in the brackets, and we make sure that we use the opposite sign in the expanded form. But for this compound angle sin a plus b, we are going to make sure we are using the same sign. So if there is a positive sign in the bracket, then there will be a positive sign in the expanded form. So this is the rule for the sin a plus b, which will give you sin a cos b plus cos a sin b. Now let's look at the proof of sin a minus b, which is equal to sin a cos b minus cos a sin b. Let's write it down real quick. Okay, let's use this pen. Okay, so now we have sin a minus b, which will give us sin a cos b and negative your cos a and sin b. Now we are going to prove this compound angle. So the first one we were looking at was your sin a plus b, sin a plus b. Now sin a minus b. So this is another type of compound angle we are looking at. Now let's prove this. Now again take the left hand side, and left hand side says this will give you cos sin A minus B will give you cos 90 degrees minus A minus B, and this is again a co-ratio. We did co-ratios in grade 11, and so you should be able to identify and write the co-ratios. And then we are going to multiply this negative in the bracket, so this will give us your cos now this is where we expanded this by multiplying this negative. So this negative we multiply with this A, and then we multiply this negative with minus B. Now we got this cos 90 minus A plus B. Minus A will remain same, minus minus will become positive, so this will be your positive B. Now we are going to group them. So we are going to group them according to the compound angles. We are going to say 90 minus A. Let's group this. And there is positive B, and we can identify a compound angle. This is 1 alpha, this is beta, and there is a positive sign. Because of this positive sign, we can identify this is a compound angle. Now we can expand this by using the rule cos A plus B, which will give you cos A cos B minus sin A sin B. So the rule here, if we apply that rule of cos A plus B, we will say cos 90 minus A cos B plus minus your sin 90 minus A and sin B. So if there is a positive sign in the brackets, please remember to use the negative sign if we are using the rule cos A plus B to expand. Now we write the co-ratios again. Cos 90 minus A becomes your sin A and cos B. This is again the co-ratios and minus sign. Why? Because now we are using the rule sin A minus B, and the negative sign in the bracket, there is negative sign in the bracket, so the negative sign will remain negative. So sin 90 minus A, again this is a co-ratio for cos A, and we can say sin B, which times with sin B. So hence proved that your left hand side is equal to your right hand side, and so sin A minus B is equal to sin A cos B minus cos A sin B. So these are the compound angles. Okay, now we are looking at some of the questions. Okay. Please, I would advise you to keep your grade 12 formula sheet next to you. You will be able to identify different formulas given to you to use in the compound angles. That is your sin A minus B, which is equal to your sin A cos B minus cos A sin B, and cos A minus B, which is equal to cos A cos B plus sin A plus sin B. Then another type of formula which is present in your formula sheet is your sin 2A, which is equal to 2 sin A cos A, and then we have the another compound angle, your sin A plus B, and your cos A plus B, and your cos 2A, which could be equal to cos squared A minus sin squared A, or your 1 minus 2 sin squared A, or 2 cos A minus 1. Now we have a question. We are going to look at how to expand each of the following different type of angles using the compound angle formula. So let's quickly write the question. It says expand the following using the compound angle formula. So the first thing we are looking at is your sin A plus B. So we are looking at sin A plus B. Note, we have to identify the pattern first, and then we are going to go and solve for it. So sin A plus B, if you go back and look here on the screen, sin A plus B, the pattern is sin, cos, cos, sin. So we will write that pattern. So we will say this is equal to sin cos, cos, sin. Another rule we talk about when we are looking at sin compound angles is that whatever sign is in the bracket, it remains as it is. So there is a positive sign in the bracket, we will say the positive sign will remain positive. Now angle A and angle B. So sin A cos B and cos A sin B. So this is how we will expand. Now they could give you something called your sin theta minus 45 degrees, and that will give you, for example, we will write the angles or the pattern first. So that is your sin cos, cos, and your sin. Now there is a negative sign in the bracket, we will put negative sign in between these two. Now theta, sin A, theta, cos theta here, sin 45, we will write 45 degrees here, and with sin this side we will write sin 45. So this is how we will expand. They could give you something like cos x plus y. Now please note we are looking at the cos compound angles here and not sin. The rules for sin and the pattern for sin is different from the cos. So when we are looking at sin, we say the pattern is sin, cos, cos, sin. But when we are looking at the cos, the rule or the pattern says cos, cos, sin, sin. So the pattern here is your cos, and then we write cos again, leave little bit space out, and then we will write sin, and again we are going to write sin. Now look at the sign in the bracket. This is positive. In the cos, we say whatever is there in the brackets, we are going to change that into the opposite sign. So if there is a positive sign in the bracket, we are going to choose the negative sign in the expanded form, and if there is a negative sign in the bracket, we are going to use the positive sign in the expanded form. Now we have these two angles x and y. We are going to give each one each angle. So cos x and sin x and cos y and your sin y. So this is how we distribute the different angle, and this is altogether your expanded form. Now let's try another example. We can use let's say, okay, slightly different example we can use, and that is your 3x. What if this is 3x minus y? Now from sin we can identify we are using the sin compound angle rules, and the pattern is sin, cos, cos, sin. So let's write the pattern first. Sin, cos, cos, sin. Okay, so this is the pattern, and there is a negative sign in the brackets. We are not going to change this negative sign. This will remain as it is. There is your 3x, and there is your y. Again, there is your 3x, and there is your y. So this is the expanded form for these type of questions. We are looking at the compound angles of sin and cos. Now they can use, they can also give you expanded form, and they can ask you to write your single term. So the question would say that question would state that use the compound angle formula to write each of the following as a single term. So how we can write each of the following as a single term? Now let's see. We are going to write it as a single term. The question, I'm going to change the color so you know that we are looking at the different question. We can't see this color, so let's use pink. Okay, so the first part, it says cos 2b cos b. We'll do the easier one first, and then we'll go to the more difficult one, right? So this is sin 2b and sin b. Okay, now cos 2b cos b plus sin 2b sin b. We are going to identify different part of this question. There is a positive sign, there is a pattern cos, cos, sin, sin. Okay, from the pattern we can deduce this is a cos compound angle, and for the cos compound angle we say that we are going to use the opposite sign in the bracket from the expanded form. So there is a positive sign in the brackets, we will use negative sign. Now this is 2b, this is one angle, and b, this is another angle. So we will say 2b and b. So the answer in the simple term or single term is cos 2b plus sin 2b sin b is equal to your cos 2b minus b. I hope this is easy. If you have any question, please feel free to ask. You can use the comment section or you can DM me and I can explain to you whatever you have confusion in. Okay, now let's use another expanded form and we are going to figure out if it is using the sin compound rule or they are using your cos compound rule, and we will go from there. So sin 5a cos b minus cos 5a minus, no, not minus, times it with sin b. Okay, now I'm going to change the pen color just to show you different parts, right, so you don't get confused. Now there's the pattern: sin, cos, cos, sin. This pattern we said is we can identify this compound angle is using sin rule. Whether it is using plus rule or minus rule, we can use this sign to identify. So when we are using sin, we said that the same sign will be in the expanded form and in the single term. So if there is this negative sign in the expanded form, then there is a negative sign in the single term as well. So we will say negative. Now sin 5a cos 5a, this is one angle, and cos b sin b is another angle. So we will say 5a and minus b. So sin 5a minus b. So this is how we can identify and solve for the expanded formula, and we can use from the expanded formula single term. Okay, now let's use another type of question, their favorite type of question for exams. They we can ask you, use the compound angles to prove. This is what most of the kids are scared of, proving left hand side is equal to right hand side. So sin 180 plus theta is equal to your minus sin theta. Now we are going to prove that. Now use our compound angles. We can say, let's just continue with this pen, right? We are going to use this left hand side to prove. This is my favorite side to prove any identities or angles. So this is sin 180 plus theta. We are going to use the compound angle to expand this notation. This is sin. So from sin we can deduce that we are going to use the pattern sin, cos, cos, sin. Okay, if we have sin, then the bracket, whatever sign is in the bracket won't change. So there we go, positive will remain positive, and sin 180 degrees sin theta, so this will be cos theta, and then cos 180 degrees and sin theta. Now this is the expanded form. Now sin 180 degrees is equal to 0. Use the calculator to find the value, and then we times it with cos theta plus cos 180 degree is -1, and there is your sin theta. Now simplify, and this will become minus sin theta. Hence prove that your left hand side is equal to your right hand side. Okay, now we can use another example where they can ask you to simplify without using the calculator. So let's see. Simplify sin 105 degrees without calculator, right? I'm just going to write calc, not calculator. Whole thing I'm not gonna write. Okay. Now we are going to write this sin 105 as a sum of your special angles. So this is your duty to find out which two special angles will add up and make sin 105. So in this case, I can tell you for this one, right? But with practice you will know which angles to use almost immediately whenever you see anything, any question like this. So sin 105 will be sin 60 plus 45. Now we are going to use the compound angle sin 60 cos 45 plus cos 60 sin 45, and then we are going to identify the values and put in the values, and that will give you sin 60 is equal to root 3 over 2. Again, these are your special angles, so you must know the value without the calculator. You must be able to draw the 30-degree triangle, 60-degree triangles, and 45 degrees triangle, and figure out from there which side is equal to, which trig ratio is equal to what. So cos 60 is equal to half, and sin 45 is equal to root 2 over 2. Now we simplify, so we times this together and this part together, and we will get root 6 over 4 plus your root 2 over 4, and then lastly, finally, we can write it as a single product, and that is your 4 in the denominator and root 6 plus root 2 in the numerator, and this will give you your answer. Sin 105 is equal to root 6 plus root 2 all over 4. I hope you understood so far. So this was the lesson discussing your compound angle sin A plus minus B and the related exam type questions.